Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. So in this present video, I would like to discuss the problems, solutions in question bank in Module 1, the first order and first degree differential equations. In Part B, it is the first video. There are two videos in Part B. Already I have finished Part A 2 videos, and this is the first video in Part B. And here we are going to perform some problem solutions of first order and first degree differential equations, and these questions are in question bank. So now see the first problem. Solve the differential equation 1 plus e power x by y dx plus e power x by y into 1 minus x by y dy is equal to 0. So we have to solve this differential equation, and clearly by observing this equation, I can take x by y as another variable, some v, and I can reduce the equation to the homogeneous form, or we can reduce it to variable separable form. So this equation, now I can write this equation, write the solution. I can write this equation as dx by dy plus, I'm writing dy in the denominator, dx by dy plus e power x by y into 1 minus x by y by, I'm writing 1 plus e power x by y in the denominator, 1 plus e power x by y is equal to 0. Or I can write it as dx by dy is equal to e power x by y into x by y minus 1 by 1 plus e power x by y. Now on observing this equation, I can take a substitution, put x by y is equal to v, or x is equal to vy. So we have the methods already we have seen in the regular classes. Y is equal to Vx or x is equal to Vy are the substitutions for homogeneous equations to reduce the equations into variable separable form. So here you can assume that x by y is equal to V or x is equal to Vy. Then on differentiating with respect to y, dx by dy is equal to V plus y into dv by dy. V plus y into dv by dy. Then call this as equation 1. Then what is equation 1 becomes dx by dy can be written as v plus y into dv by dy is equal to, so the right side function e power v into v minus 1 by 1 plus e power v. The total function is changed in terms of v terms and y terms only. Or I can write y into dv by dy is equal to e power v minus 1 by 1 plus e power v minus v. Or I can write it as v e power v minus e power v minus v minus v e power v by 1 plus e power v. So this v power e power v gets cancelled. You'll get minus of v plus e power v by 1 plus e power v is equal to y into dv by dy. So you can observe that the right hand side is a pure function of v. I can separate the variables on separating the variables. So on writing 1 plus e power v by v plus e power v dv is equal to minus dy by y. So write the entire function on dv side and y variables on dy side. I'm writing like this, you will get this like this. On integrating, now on taking integration, we get integral 1 plus e power v by v plus e power v dv is equal to minus integral dy by y plus log c. So what is it? Is looking like integral f dash v by f of v. So here if you assume f of v is equal to v plus e power v, then what is f dash of v? The derivative of v is 1. E power v derivative is e power v of dv. So it is looks like integral f dash of v by f of v. So the formula is log f of v, that is log v plus e power v on the left hand side, and on the right hand side it is minus log y plus log c, or v plus e power v is equal to c by y. It is log m minus log n like. What is the formula for log m minus log n? Log m minus log n is equal to log m by n. So it is log c minus log y. So log c by y. So on eliminating log both sides, you will get v plus e power v is equal to c by y. But what is v value? Already we have assumed v is equal to x by y. So on replacing, therefore the solution x by y plus e power x by y is equal to c by y. Or on cancelling out, x plus y into e power x by y is equal to c, which is the required solution of the given differential equation. So just I have substituted x by y is equal to v, so that the entire equation reduces to variable separable form, and on separating the variables and integrating and applying the formulas, you will get the solution as x plus y into e power x by y is equal to c. Already we have discussed in the class, just I am applying the formula because it is on the model of x by y is equal to some variable v. So in that way you can solve this problem. And see another problem. Solve the differential equation x into e power xy plus 2y dy by dx plus y into e power xy is equal to 0. So in the differential equations, all the problems will like only solve this one. So you are supposed to apply the model, which is, we are having several models to solve the first order and first degree equations. So you have to observe which method is appropriate to solve this model, and you have to execute that model. Now I do this by using m dx plus n dy, exact equation model. The given equation, I am rewriting the given equation. The given differential equation is x e power xy plus 2y of dy plus y into e power xy dx is equal to 0. Just dx write this side, and right side will be 0. So now the equation is in the form. It is in the form m dx plus n dy is equal to 0. Here what is m? Here m is equal to y into e power xy, because it is the dx coefficient. And what is n here? The n is equal to x into e power xy plus 2y. Then what is dou m by dou y? We have to check first the condition of exactness. The condition for exactness, what is the condition? Dou m by dou y is equal to dou n by dou x or not. This I am going to check. What is dou m by dou y? The partial derivative of m with respect to y. This is already y, this is also containing y. You have to apply UV method, and differentiating y, you get even e power xy treat as fixed term plus y into e power xy derivative, e power xy into x, or I can write it as e power xy into 1 plus xy. That is the dou m by dou y. Then what is dou n by dou x? Dou n by dou x, partial derivative of n with respect to x. Second term, we know that it is 0 because it is 2y. It is a variable y. When you are differentiating partially with respect to x, that variable treat as a constant term. So only we have to differentiate x into e power xy, x1 e power xy treat as fixed 1 plus x into e power xy derivative e power xy. With respect to x means xy will become y, or e power xy and taking outside 1 plus xy. So dou m by dou y this is, and dou n by dou x this is. These two are equal. So the condition of exactness satisfies. Therefore, what is our condition? Dou m by dou y is equal to dou n by dou x. Therefore, the equation is an exact equation. The equation is an exact equation. Then how to write the solution? Therefore, the general solution is, what is the formula? Integral m dx treating y as constant plus integral the terms of n not containing x terms into dy is equal to c. That is what? Integral m means what? What is m? What is m? X into e power xy, y into e power xy, y into e power xy dx plus integral the terms of n not containing x terms. The terms of n not containing x terms. This is containing x, so this has to be eliminated. The only term is 2y. So that is 2y dy is equal to c. So I'm taking integration, y is constant, e power xy with respect to dx integration, e power xy by, with respect to x means x1, and we'll get in the denominator y plus 2 into y square by 2 is equal to c. Or 2 gets cancelled, y gets cancelled. So the solution will be e power xy plus y square is equal to c, which is the required solution of the differential equation. So clearly in this problem we have used the exact equation method of solution. In the first problem we have gone through homogeneous differential equation. So you have several methods in variable separable, homogeneous, non-homogeneous, exact equation, and not exact and make integrating factors, linear differential equations, Bernoulli equations. If the given equation is applicable to any model, then you can apply that model to get the solution. Now see the problem. Solve the differential equation x cube secant square y dy by dx plus 3x square tan y is equal to cos x. So this also we can solve by using exact equation method. First write it is in the form of m dx plus n dy. So I am writing the given equation x cube secant square y dy plus 3x square tan y minus cos x of dx is equal to 0. I am writing this is in the notation m dx. This is m dx plus n dy is equal to 0. What is here m? Here m is equal to 3x square tan y minus cos x, and n is equal to x cube secant square y. Then what is dou m by dou y? The partial derivative of m with respect to y. So second term is 0 clearly. Only the first term t, 3x square also constant, tan y derivative secant square y, that is dou m by dou y. Similarly, what is dou n by dou x? The partial derivative of n with respect to x. So y term treat as constant, only y term secant square y write as it is. X cube derivative is 3x square. Clearly, these two are equal. Dou m by dou y and dou n by dou x are equal. Therefore, dou m by dou y is equal to dou n by dou x, and the equation is an exact equation. So if the equation is exact equation, we can write the solution easily. Now, the general solution is integral m dx treating y as constant plus integral the terms of n not containing x terms into dy is equal to c. That is what integral, what is m? What is m here? 3x square tan y. 3x square tan y minus cos x of dx plus the terms of n not containing y terms. The terms of n not containing x terms, that is entire term is 0 dy. There is no such terms. So we have to put a 0 dy. The terms of n not containing x terms. There is only one term in the n, that is x cube secant square y, which contain x cube. So 0 dy. So now we have to integrate with respect to x treating y as constant. Tan y, constant term, 3x square integration 3x cube by 3 minus cos x dx integration minus sin x is equal to c. 3 also cancel. The answer is x cube tan y minus sin x is equal to c is the required solution of the given equation. So here we have seen the exact equation method. In the second problem and third problem, we have seen the same type of model, the exact differential equation. In this model, the given equation assumed as mdx plus ndy is equal to 0. And first check the condition of exactness, dou m by dou y is equal to dou n by dou x or not. If it is exact, then go for the solution of the differential equation by writing integral m dx treating y as constant plus integral the terms of n not containing x terms into dy is equal to c. So that is the required solution of the given differential equation. So the first model we have worked out by using x by y is equal to v substitution, so that the entire equation gets into the transformed of variable separable method. And in the second and third problems, we have seen the exact equations, how to solve the exact equations, how to check the condition, and all we have seen in the second and third examples. Now I am going to solve one more problem. Solve the differential equation x plus 1 dy by dx minus y is equal to e power 3x into x plus 1 whole square. What is the equation? Given equation x plus 1 dy by dx minus y is equal to e power 3x into x plus 1 whole square. Now divide throughout by x plus 1. Divide throughout by x plus 1. Then what is the equation? Dy by dx minus 1 by x plus 1 into y is equal to e power 3x into x plus 1. This is called equation number 1. So how it is in the notation? This equation looking like dy by dx plus p into y is equal to q, where p comma q are functions of x. So it is looking like dy by dx plus p into y is equal to q, where p is minus 1 by x plus 1 and q is e power 3x into x plus 1. So this is a linear differential equation of first order in y. So can I write it here? What is here? What is p? P is equal to minus 1 by x plus 1 and q is equal to e power 3x into x plus 1. P minus p dy by dx. Just you compare these two equations. dy by dx plus py is equal to q, where p is minus 1 by x plus 1 and q is equal to e power 3x into x plus 1. So if it is the linear differential equation, what is the solution? We know that the solution will be y into e power integral p dx is equal to integral q into e power integral p dx plus c. The solution will be in this form. So when writing the solution, first we find e power integral p dx. Here also I can write e power integral p dx. That is e power minus 1 by x plus 1 integral dx. That is what e power minus log x plus 1, or it is 1 by x plus 1. The value is 1 by x plus 1. So now the solution will be, therefore, e power integral p dx value is 1 by x plus 1. Now the general solution. Is y into e power integral p dx is equal to integral q into e power integral p dx plus c. That is y into 1 by x plus 1 is equal to integral. What is q here? What is q? E power 3x into x plus 1. Here you can see that q value e power 3x into x plus 1. So e power 3x into x plus 1 into e power integral p dx value 1 by x plus 1 of dx plus c. So x plus 1 will get cancelled. So e power 3x integration, e power 3x by 3 plus c is on the left hand side y by x plus 1. This is the required solution of the given differential equation. So this is the linear differential equation model. The standard form is dy by dx plus p of x into y is equal to q of x. And the general solution is y into e power integral p dx is equal to integral q into e power integral p dx plus c. This is the general solution. So this is the last before model. Last one is Bernoulli equation. This is linear differential equations of first order. So this given problem is applicable to the linear differential equation of first order because it is in that model dy by dx plus py is equal to q model. So we can solve that problem by using linear differential equation of first order. So there is one more problem and I will solve. You have to do integration. I will solve up to some part. You are supposed to solve the remaining case because you also need to practice. So what is the given problem? Solve the given differential equation dy by dx is equal to x square minus y square by 2xy. So first we have to observe which method is applicable to this given problem. Which method is applicable to this given problem? You can use mdx plus ndy is equal to 0 model, or you can do the homogeneous equation. Second model. First model is variable separable. Second is homogeneous equation. So to apply homogeneous, you have to observe that the given equation is a homogeneous differential equation or not. So clearly it is a homogeneous function. The right hand side is a homogeneous function of degree 0. The numerator is k square by k square, k power 0. That means homogeneous function of degree 0. So to solve homogeneous function, put y is equal to vx. Then what will be dy by dx? Dy by dx is v plus x into dv by dx. Clearly, first step you write clearly, it is a homogeneous differential equation. So on putting dy by y is equal to vx, what you will get? v plus x into dv by dx is equal to x square minus y means vx whole square. That is v square x square by 2x into, instead of y we replace it by vx. So taking out x square in the numerator, 1 minus v square by 2vx square, and this x square, the square gets cancelled. Here x dv by dx, and it is minus v, and that is 1 minus v square minus 2v square by 2v. So this is equal to 1 minus, this I can write. What I can write, it is 1 minus 3v square by 2v, and on the left hand side x dv by dx. Now there is a possibility of doing variable separable form. So take v variables on dv side and x variables on dx side. Then how you can write? 2v by 1 minus 3v square dv is equal to, what is the case here? On separating variables, what you are going to do, that you have to write here on separating the variables. 2v by 1 minus 3v square dv is equal to dx by x. And now on integrating, integral 2v by 1 minus 3v square dv is equal to integral dx by x plus log c. But what is integration? Integral f dash of v by f of v dv. What is the formula? The formula is log f of v, log modulus f of v, or simply f of v. Here, suppose if you assume f of v is equal to 1 minus 3v square, then f dash of v is minus 6v. But there is only 2v. So for that I multiply with minus 3. With minus 3 in the numerator and minus 3 in the denominator. So that the numerator will be minus 6v by 1 minus 3v square. So the integration now it becomes 1 minus 1 by 3 constant log 1 minus 3v square is equal to log x plus log c. So now I can write it as log 1 minus 3v square whole power minus 1 by 3 is equal to log cx. Or what I can write, 1 by 1 minus 3v square whole power 1 by 3 is equal to cx. But what is the v value? V is equal to y by x. This is the final substitution. Y is equal to vx or v is equal to y by x. Both are same. So on substituting, we'll get the final solution. So just replace v for y by x and write the complete solution. So in the first model, we have substitution x by y is equal to v. In the fourth model, we have taken y by x is equal to v. In the second model, we have taken it as an exact equation. And in the third model also, we have solved it by exact equation method. And in the fifth problem, we solve it as a linear differential equation of first order in y. So these are the questions involved in the part B, first phase solutions. And we will see the second phase solutions in the next video. That is solutions of first order and first degree equations, question bank part B2, that we'll see in the next video. So with these few problems, and this is reference is question bank of the course Differential Equations and Vector Calculus, BT23, published by Ministry of Aeronautical Engineering, Dundigal, Hyderabad. And with the few words, I say thank to everyone. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.